Hello everyone, today I'm going to show you how you can add a simple player controller with input handling to your Python game based on yesterday's video. First, what you want to do is add a new player class with a constructor. And the only attribute we need right now is our position. We will just set this to 0, 0 for now. Then we want to create our player. And we don't need any parameters for that. But if we launch our game right now, still nothing's on screen. This is because we are never actually rendering the player. So to do this, we will add a new draw method. We need the surface parameter to tell PyGame which surface to actually render to. In this case, this will simply be our screen variable. As you can see right here, we need to pass in our surface. Then the color we want to use, I will go with blue. Our center, I will just go with self.position. And our radius, I will use 10. Every other argument is optional. If we run this again, you still can't see anything. This is because we are never actually calling the draw method. We need to call it after we have called the screen fill function. This is because otherwise it would overwrite our player. If we try this again, you can see a little blue ball being rendered in the upper left corner. But that's an issue. Optimally, we would want position 0, 0 to be at the center of our screen. To do that, we need to offset our position, our drawing position, by the screen dimensions. So let's just get a hold of them for now. With the PyGame surface get size, you can get the size of a surface in the form of a tuple, and by writing it down like this, you can basically split it up right away. Then we want to create our new screen space coordinates value. We will just use our position with the X dimensions and the Y dimensions halved and then added to it. This is because if we were to use the dimensions directly, we would just end up at the other corner. Then we need to use the screen space chords in the drawing function. And if we try this again, I had an issue. Of course, I forgot to index into the position. Now if we try this again, you can see our player being rendered at the center of our window. But we still can control him. To do that, we need to add a bit of additional event handling. First, let's check if the event type equals PyGame key down. This means that a key has been pressed down, but this event only occurs in the instance that a key is pressed down. It will not reoccur every single tick. So we need some additional state, which we will get to later. Let's just check if the key being pressed down is W. And now let's get to the state I mentioned earlier on. We we will just use movement attributes for our player. I will use self.movex and self.movey to store in which direction the player should move based on the inputs the game has been given. And whenever a key is pressed, the direction in which we want the player to go should be added to that movement attribute. So if we press key W, obviously we want to go down, so we have to modify the movement vector in the Y direction. So let's just set it to -1. And you might wonder why we are setting it to -1. This is because in computer graphics the Y-axis is reversed in comparison to our maths classes. But if we do all this, our player will still not move. I can show you right now. I'm pressing the W key and it is not going up. This is because we are still drawing the player based on the position it stores, but we are not updating it anymore. So let's add a new update method. In here we want to offset the position based on our movement attributes. And let's update the player right before drawing him. Let's try this again. And now you can see our player is going upwards. But I have long released the W key and it is still going upwards. The question is why? Well, the answer is simple. We are never handling a key released event. So let's implement this. PyGame key up event means that a key has been released. In here we are checking if the event, if a key being released is our W key. And we are just resetting the movement vector in the Y direction. So if we press W and release it again, our player stops moving. Let's do this for every other key now. And the same with the keys being released. And now if we try again, our player can move in each direction. One issue you might be noticing is that when our player moves diagonally, he moves significantly faster than if he moves in just a singular direction. This is because our movement vector isn't normalized. This isn't some magic computer graphics normalization, this is just the regular vector normalization you have learned about in your maths classes. And if you did, you might know that now the first thing we need to do is calculate the length of our movement vector. I will take the maximum of the length of a movement vector and 1, because if none of the movement attributes are set, we will get a length of 0, and when we divide the movement attributes later on by the length variable, we will just get a division by 0 error and the game will crash. But other than that, we can just use the square root of the power of 2 of the move x and the power of 2 of root of move y. Then we need to create the normalized vector. Now we can add a simple quality of life feature. Imagine you want to buff or debuff your player later on. In order to do that, you can just add a simple speed attribute to him and modify the normalized movement vector by multiplying it with that speed attribute. Let's just set it to 10 by default. And let's call the new variable movement. We will just multiply each element in the normalized vector by our speed attribute. And instead of offsetting our position by self.movex and self.movey, we will offset it by our movement vector. Now if we try running our game again, no, we are getting an error. This is because the square root function is defined with the maths library. Now if we try moving it, you can see that we are moving significantly faster than before, but it doesn't matter whether we are moving at in a diagonal direction or a singular direction, the movement speed is all the same. So, I hope you have learned something from this video, and I am excited to hear about your questions or recommendations in the comments.